Hello, everyone. So my name is Ron McGeary, as you guys already know from my YouTube channel. And so just to get things started off real quick, so I've got over 30 years in maintenance and maintenance activities, PMs in engineering as well. So the maintenance leadership, well, my three E's. A lot of this information I'm talking about is on teacherspayteachers.com. And the name of my store is obviously Ron-McGeary, all lowercase letters. So for today, for my YouTube channel, I want to be explaining a bit about electric motors, the motor principles, what makes those motors turn or rotate when we hit that go button or when we plug them in. Okay, so how do these motors actually work? I'll be just hitting on some single phase and three phase motors briefly, but this here PowerPoint or this here webinar here, it's just about how do motors work? What are the principles of motors? Okay, it all got to do with this little thing called magnetism. There's north and south poles, right? I'm sure you guys have learned that in high school, maybe even grade school, maybe you went to college and so forth. But in industrial maintenance, electromagnetism plays a huge role. So no matter, so let's say if you learned it in 8th grade, you might say, hey, I'm never going to use this, so I'm not going to pay attention to it. Well, guess what? You are going to be using it a lot in the industrial maintenance world, so you got to have it, right? So just start off here real quick. I don't read every word of every PowerPoint or every slide or anything else like that, but I will read most of it so you can get the gist of what we're trying to say here. So electric motors are used to convert electric energy into mechanical energy, of course. And so we got our 480 volt motor plugged into this let's say the PLC, and then we hit the go button, okay, and then actually the motor will be connected to a variable frequency drive. But stay tuned for that YouTube channel or that YouTube webinar as well. I'll be talking about VFDs, variable frequency drives, programmable logic controllers, and motors, all through automation. Okay, so when that VFD where you hit the go button, hit the start button, you're going to have electric energy being converted to that mechanical energy. As that motor rotates, what does it produce? It naturally or inherently produces torque. But how does it get further than that? Magnetism plays a huge role in it. They use magnetism and electric currents to operate. They're turning and turning and turning. And why are they doing that? They're trying to find something. They're trying to find that north and south pole, right? So, and we'll get to that here in a second. So a permanent magnet will attract and hold magnetic materials, okay? Iron and steel and so forth, all right? Copper nails, etc., all the way through here. This is some of the stuff you may have learned in elementary school, but bear with me, all right? The permanent magnet is able to attract magnetic materials of its own inherent, didn't I say that word? Yes, I did. Inherent magnetic force, which is referred to as a magnetic field. And you got to have that. If there's no electromagnetism or any magnetism, if there's no magnetic field, okay, then we're talking about the lines of flux. So if you're a welder real quick, when you weld, right, you got your stick in your hand, you got your welding rod clamped to it and so forth. The welding rod actually has a flux in it. And so it's all got to do with electricity, all right? The magnetic field of a permanent bar magnet is represented by lines of flux. Now you can't see it, obviously, but it's there, okay? North and south poles. The stronger the magnetic field, the greater the number of lines of flux. Lines of flux are assumed to have a direction of movement from a north pole to a south pole magnet, as shown in this here little diagram, okay? And so actually that's how our Earth rotates, and the sun and the planets and the space, right? So it's all got to do with electricity. So electromagnetism right here. And so here we go. A magnetic field is also produced around a current carrying conductor. What is a conductor? A conductor is anything that can transmit the free flow of electrons. All right. So, for example, we talk about the wires or conductors. A wire can conduct the free flow of electrons. That is a basic definition of basic electricity, free flow of electrons. Okay. And so this here is our power source all the way through here, right? And then all the way through, Direction lines of flux. Use your little thumb there will show you the left-hand conductor rule. And then all the way through here, a free flow of electrons are going through from this point to that point, from my battery source. Okay. All the way, the shape of the magnetic takes the form of concentric circles. You'll learn about concentric and eccentric as we move forward here. The relationship between the direction of current flow through a conductor and the direction of magnetic field created can be shown using the left-hand conductor rule. All right, so here we go. When current carrying conductor is shaped into a coil, all the individual flux lines produced by each section of wire join together to form one large magnetic field. Okay, that's what you have around here. Okay, the magnetic field produced by a current carrying coil resembles that of a permanent magnet. If you've never experienced a permanent magnet before, they're very, very strong because there's lots of lines. The lines of flux are very strong. There's lots of them there. That's what makes it permanent. All the way through here, so the magnetic field of a wire coil is much greater than the magnetic field around the wire before being formed into a coil, and can be further strengthened by placing a coil of iron in the center of the coil. And to be honest with you, this is how motor starters actually work. Okay, motor starter is nothing more but a contactor, and auxiliary relay and overload relay, auxiliary contact and overload relay. And so here we go. And this is we're inducing electricity into the coil, which is A1, A2. And guess what? On the inside of that contactor, you have metal, and then you have little copper conductors wrapped around that metal, and that is your core. A motor stator, okay, is constructed using windings or coils of wire are wound on a iron coil all the way through here. So this is a typical motor of stator coils. The stator stays stationary and the rotor rotates. That's what's all inside of our motor, okay. The polarity of the poles reverses when the current flow through the coil reverses, all right. So we got your north pole, south pole, and guess what? When we reverse, they reverse. Now in here, just here a little bit, you'll see this is my stator coils in here. We're going to get a close-up view of this as well. But when you do take apart motors, maybe rebuild, not too many people rebuild motors anymore. I don't know really why. I do know why, but as a matter of fact, because we're a throwaway society. We don't troubleshoot no more, right? And so when the technician says, hey, the motor is bad or faulty, they hardly ever say faulty. I'm not about the only one that says faulty out there, right? Then they just chuck it away. And that's it. Motor rotation. And so electric motor rotates as the result of the interaction of two magnetic fields. Okay? All the way through here. And so they're opposites. They keep turning. The electromagnet is the moving armature part, and the permanent magnet, the fixed, the stator part. After it turns part way around, the force of attraction between the unlike poles becomes strong enough to keep the permanent magnet rotating. Okay? North and south, always trying to find each other. They never do, right? That's what keeps it turning. Unless you turn it off. The rotating electromagnetic turns and continue to turn until the unlike poles are lined up. At this point, the rotor will normally stop because of the attraction between the unlike poles. So there you go. Commutation is the process of reversing armature current at the moment the unlike poles of the armature and field are facing each other, thereby reversing the polarity of the armature field. Like poles of the armature, they repel each other, cause the armature rotation to continue. That's exactly what we want. We want that motor to keep on turning. Now this is the basic part of it, right? This is what's going on inside that motor. Now, if you do in the field, when you do want that motor to turn the opposite direction, what do? You're going to hear me talk a little bit later about legs, okay? You got L1, L2, and L3. These are all my phases or legs that are going into my disconnect or my contactor, my motor starter, and then I can switch any of those two leads, and guess what? The motor is going to reverse direction, all right? We'll get more into that a little bit later. All the way through here, the current carrying conductor, when placed in and out at right angles to a magnetic field, tends to move up at right angles to the field. We're talking about right angles and vectors. All this is happening on the inside, believe it or not. There's a lot to it, okay? There's a lot to it. One method used to determine the direction of movement of a conductor carrying current in the magnetic field is called the right-hand motor rule. So here you go. So the direction of conductor movement, right? Direction of current flow all the way through here. Then your fingers are pointing this direction of the magnetic field. So it's pretty easy to do. You got your thumb out here and so forth. Get your finger just like this. And so the direction of conductor movement would be your thumb. All right. It's very important to understand this to get a grasp on really basic electricity and basic motors. How do motors work? So once you understand how motors work, guess what? Then you can start programming variable frequency drives. Okay, because you're going to get a fault or some type of error code on a VFD. That's going to tell you what part of that motor is not working. Then you have parameters inside the variable frequency drive that you can adjust to make that motor do what you want it to do. Okay, the motor by itself is just a dumb device, and along with the VFD, put those two together, the VFD is a programmable device. Now you can tell that motor exactly how to behave. All right, that's what I always said before. A VFD controls the behavior of a motor. Okay, when the lines tend to straighten out, they cause the loop to undergo a rotating motion. The left conductor is forced downward and the right conductor is forced upward, causing a counterclockwise rotation of the armature all the way through here.
Direction of mechanical force can be easily determined by
There you go. North and south poles. All right, so very important. All right, a practical motor armature is made up of many coils of conductors. Okay, the magnetic fields of these conductors combine to form a resultant armature field with the north and south poles that interact with those poles of the main stator field to exert continuous torque on the armature. Now we're going to get at the different types of torque with motors. All right, there's just not one torque. There's many torques. All right, like acceleration torque, breakaway torque. All right, these things that we have to understand to be able to control behavior motor, to understand how VFDs work as well. So very important. Motor classifications real quick. So we have AC and DC motors. Now what's not shown here, which is in another webinar, are servo motors. Okay, servo motors are used in robotics. Okay, used on CNC machines, computer numerical control machines, and so they've been around for a long time now, since the late 80s. I seen the very first Cincinnati Millicron when I was in Ohio at a machine shop. Now, it did take away some jobs, right? So I was part of a union shop, but we didn't fire those individuals. What we do? We retooled them. We trained them to do something else. So there was no one else being relieved of their positions. All right. So DC motors and AC motors. Now we have DC and AC motors throughout the world, throughout the industry, all the way through. So there's a lot to it for sure. Okay. So let's just do the AC motors, right? Single phase and there's polyphase, there's three phase all the way through. And so all that means, and so now I have another webinar that talks about what the phases are. So a single phase has got one hot wire and one neutral, okay? And you have a ground wire. And so the three phase, you got three hots, right? You got three hot, which means when I say three hots, you got three conductors with the free flow of electrons flowing through them. So those are definitely hot wires. So typically on, like say, a 480 volt system, you got brown, orange, and yellow. That's what the color codes are for each leg or each phase. Okay, all the way through here. Now DC motors, you got permanent magnet, series wound, shunt wound, compound wound. I'm gonna have webinars on all these motors. You guys will help you understand. So here we go all the way through your single phase and polyphase, induction, synchronous motors, induction again all the way through here, and in synchronous motors, wound round motor, squirrel cage motor. So we have an abundance of squirrel cage motors in industry. Okay, those are mostly used, and there is like a squirrel cage that's in there. As the rotor rotates around that squirrel cage. And so we'll talk more about that a little bit later. I'm going to have webinars on each different motors that there are here. Split phase capacitor start motors, permanent split capacitor, always shaded pole. There's going to be a webinar on that guy as well. Hysteresis, reluctance, and permanent magnet all the way through here. And so there's going to be a lot of good information on the webinar, so stay tuned to my YouTube channel. Like and subscribe, right? Like and subscribe all the way through there. Stay tuned, all right? And that's me, and that's it. And so thank you very much for watching and paying attention. And so if you have any questions or anything else like that, again, one more time, like and subscribe. And there's my email address right there. And so don't forget about teacherspayteachers.com/Ron McGeary. You'll see my store there. Plenty of valuable information to help you in the maintenance industry. Other than that, thank you very much for listening and pay attention to what I'm saying. And we'll see you next time. Thank you.